of this virtual day is to get us ready for the Chapter 1 quiz, which will be going live tomorrow in Blackboard. So just a couple of things. First of all, I've provided you here a breakdown of the Chapter 1 quiz. Excuse me. So each of your chapter quizzes, and this is going to go for all semester, each of the chapter quizzes is a 10-point quiz, and this particular quiz is going to be largely calculation based. So the things that we talked about in the last 2 days of lecture, Wednesday and Friday, those are going to be the primary foci of this quiz. And so you're going to see stuff on conversions. That's temperature conversions, metric conversions, unit conversions, stuff that we got into on Friday. You're going to see stuff on density, which we didn't talk about explicitly, but was talked about in your lab. And so density calculations, mass over volume, being able to manipulate those accordingly. And then the last 20% is going to be about matter. And so this was something that you had to cover exclusively on your own. I assumed that the material in question was something that you probably saw in a previous course. And so a better use of our time was to talk about things that were a little bit more difficult and to give us a little bit of time to review. And that's kind of the genesis of this session, honestly. Other things to know about the quiz. It is a timed quiz. You will have 30 minutes to complete it, and it is proctored. Proctorio will be required for you to take the quiz itself. Most of you have gone through and done proctorio with your proficiencies. The process is essentially the same. If you do have internet connectivity issues at home, I would strongly suggest trying to figure out a way to do it while you're here on campus. So if you're a commuter student in particular and your internet's kind of spotty, proctorio does log if you leave. It will allow you to come back, but the whole process of leaving and coming back obviously costs you time. And 30 minutes is certainly enough time to do this quiz, but you don't want to have to sacrifice some of that time because you have connectivity issues at home. So my strong encouragement and recommendation for you is, if you have connectivity issues at home, it would be a really good idea to try to figure out a place to do it here. We've got some computer lab areas on campus. If you're running with a laptop, you can connect into the campus Wi-Fi, and you should be able to pretty much do whatever it is that you need to do. But don't let connectivity issues at home be the thing that gives you a good or a bad grade on this quiz, because this quiz should be pretty easy for most of you. So with all of this said, I wanted to go through and do a couple more of our conversion problems just to kind of get used to things, just to kind of get on the right page again. And then I wanted to open it up to questions. One of the things that you'll notice in my reviews is that I try to make the review sessions very student forward and student driven. So I'm going to open it up for questions here in a couple minutes. That's what I need you to do. I need you to ask questions of me. I need you to participate here, because ultimately that's going to be what kind of lets us into how well we know things and where we might be struggling. So if you have questions about things, make sure that you get them into the chat or raise the question here on Zoom, because chances are if you have a question, there are others that have a similar question as well. So I'm just going to do a couple of problems here. These are just generated by me. So first one, let's convert 19.55 cubic feet per minute to liters per hour. So in this, we are combining two concepts from our discussions of unit conversion on Friday. First, we have a combination unit here, 19.55 cubic feet per minute. That is 19.55 cubic feet in the numerator, and 1 minute in the denominator. And so we ultimately want to convert this to liters per hour. To do that, I'm going to need some conversions. Now, one of the conversions that I will pull from is I can show this to you. This is your equation sheet that you'll be given as part of the quiz. And you can see on this equation sheet, you've got a lot of equations. Most of these aren't relevant to us yet. They will be at some point. But you can see you've got your temperature conversion equations here. That's going to be useful to us. And then also down here, we've got our conversion table here as well. And so what's really going to be interesting for us is we're trying to go from cubic feet to liters. And so there's no direct conversion on here, but there are some indirect conversions that we can pull from, meaning I do know that every cubic foot is 0.02832 cubic meters. And I know that every cubic meter is 1,000 liters. So I can work with that, and coming back to my whiteboard, I know that every cubic foot is 0.02832 cubic meters, and I know that every cubic meter is equal to 1,000 liters. So by setting up my dimensional analysis correctly, I can see that my cubic feet will cancel, my cubic meters will cancel, and I'm left with liters. That takes care of the numerator of this conversion. Now we need to take care of the denominator. How many minutes in an hour? Well, most of us know that there are 60 minutes in an hour. What we have to make sure that we do is that we set it up appropriately. Minutes is in the denominator of the fraction we're trying to change. So we need it in the numerator of the conversion to get rid of it. So 60 minutes go in the numerator, 1 hour goes in the denominator, and my minutes cancel. And so I'm left with, in the end here, liters in my numerator, hours in my denominator, which is exactly what I was trying to get in the first place. Now I just need to do the calculation. And so for this calculation, 19.55 multiplied by 0.02832 multiplied by 1,000 and multiplied by 60. Everything in every one of these denominators is a 1, so we don't actually have to put in those calculations. We get a value according to our calculator, 33219.36 liters per hour. Now, this is going to be subject to significant figures, just like any other calculation is. I can see here that I have 4 significant figures in my starting calculation. I have 4 in this conversion. These other 2 conversions are exact, so they do not influence significant figures. So I am going to have an answer that needs 4 significant figures. So counting from the left, 1, 2, 3, 4. That 1 is my last significant digit. So it's influenced by that 9. I can show this answer as one of 2 ways. It's either 33,220 liters per hour, or if I wanted to further avoid any kind of ambiguity here, I could use scientific notation. 3.322 times 10 to the 1, 2, 3, 4, 10 to the 4th liters per hour. So keep in mind, that is always a possibility, is if you have a number like this where the number of significant figures could be kind of viewed as ambiguous, you know, you've got zeros leading it or zeros trailing it, scientific notation will always give you the exact number of significant figures that you're looking for. Let's go in a slightly different direction. Okay, haven't talked a lot about density, but a good place to bring it in here. What is the volume of a block of aluminum that has a mass of 23.44 grams? The density of aluminum is 2.69 grams per milliliter. Well, for density, we have to think about and include that density equation. The equation for density is that density is equal to the mass of an object divided by the volume of that object. Now, what you put in as mass and volume can be a variety of different units. In this case, we're talking about grams and milliliters, but it could technically be anything. So for problems like these, we're given the density, so that's my value of D. We're given the mass, that's my value of M. This becomes a practice, an exercise in algebra. 2.69 grams per milliliter is equal to 23.44 grams divided by the volume. The volume here is unknown, that's what we're trying to find. So this is where your algebra skills have to come in. Now, quick trick I always use is if I have a variable in the denominator of a fraction and I have some sort of completed set on the other side of the equal sign, easiest way to manipulate that is just to have them switch places. And so if I do that, V for volume is equal to 23.44 grams over 2.69 grams per milliliter. We can see from a unitary standpoint, the grams will end up canceling. 23.44 divided by 2.69 gives me 8.71. The unit here is 1 over milliliters, which any math professor worth their salt will tell you that the reciprocal of a reciprocal is the unit that we're looking at. So 1 over milliliters would be 8.71 milliliters. And so from this perspective, this is really all that we need to do to make sure that we are looking at things in the right direction and using the density equation correctly. So if you're kind of weak in your algebra, there are other ways to go about this that would work just as well. And so what I'm going to show you here is there is another way of doing this same kind of problem, taking a dimensional analysis approach, just like we did in the top problem. So I'm going to cut this up top here. One thing I want you to pull out of our discussions of dimensional analysis is that literally anything can be pulled into a conversion factor if we find some amount of equality with it. In the case of density, density is an equality in some kind of way. What it is saying is that for aluminum, 2.69 grams of aluminum are equal to 1 milliliter of aluminum. And remember, anytime we can do any kind of any kind of equality, that becomes the need for a conversion factor. So another way of doing these density problems, instead of messing with that density equation, is to use it from a dimensional analysis kind of standpoint. If I have 23.44 grams of aluminum, and I want to convert it into milliliters of aluminum, a volume, well, that density can be used as a conversion factor where I say 2.69 grams of aluminum are equivalent to 1 milliliter of aluminum. My grams of aluminum cancel. I'm left with milliliters of aluminum, which is what I want. I get the same exact calculation that I had before with the same answer, 8.71 milliliters as the total. So if you're not as algebraically inclined, and if you're not, that's completely okay. Algebra is not always the easiest subject matter for most students. So if this is something that you struggle with, but you understand the fundamentals of dimensional analysis, then you can go through and do this from a dimensional analysis standpoint and end up in the exact same place that you were before and with the exact same correct answer. So something to keep in mind as you're kind of traversing through some of these calculations. So to that point, this is the part where I'm going to open it up for questions from you guys. Is there anything that you want to talk about, anything that you are just unsure of that would bear some discussion here in this review session at this time?
There's gotta be some people.
All right, no questions so far? Everybody's good. All right, then let's do this. Let's do some practice problems here. And instead of me going through and doing all of the work, I'm going to put some up here, let you do them on your own, and then we'll go through the answers together after a couple minutes time and just kind of make sure that we're doing things right, we're on the right page. So all right, go ahead and work on this conversion then. Determine the area of a football field, which we're going to estimate to be 6,600 square yards. Convert that into square kilometers. So there is your conversion table. I will rewrite the problem on here. Give you a couple minutes and let's see what you come up with.
Shit. Okay, think about it differently. We need to take yards into miles, right? So 1 mile equals 1.09. Okay. 6,600 into
Okay. open this up to anybody. Anybody feel confident, want to walk us through what the process is? Talk me through it so that we can get to the right answer. All right, no one wants to? Okay, all right, Ben, since you put yourself in here, let's walk us through your process. You got 7.2 square kilometers. Let's see where that takes us. So how did you get it? What was the first thing that you did?
Oh, wait a second. Okay, so I put on there 66 0 yards, and then I went to I multiplied that by 1.094, and like my yard squared and my yard squared canceled out, and then I divided that by 1,000, because 1,000 square meters is equal to 1 kilometer squared, and I think that got me 7.2. But I think I might be incorrect on that.
Okay,
I'm not too sure.
So I'm drawing here on the screen what you just described.
Wait, where did I mess up?
Does that look right, Ben? Is that what you did? All right, you're muted.
Actually, I think I messed up. I'm not sure if you can see that. I don't think you can see that, but I got the meter squared on the top next to it. I don't think I was supposed to do that. Or actually, yeah, I didn't do that. I didn't divide the 1.04.
Okay, so Ben's given us the general right idea. There are two conversions that we're going to have to use. We cannot go directly, none of our conversions here take us directly between kilometers and yards. So we are going to pick on one of these ones, and we have to pick on that metric conversion between kilometers and meters. Both of those steps were correct in terms of what you're supposed to do. The problem is these are conversions between yards and meters. These are conversions of distance, not of area. Now, to fix that, it's a relatively simple proposition. It's a relatively simple fix. What we need to do is, because this is yards squared and this is only yards, we need to square that conversion. And similarly, between the meters and the kilometers, we're going to need to square that conversion as well. So in long form, what that looks like is 6,600 square yards 1.09 or 1.094 yards per meter. Now, because this is square yards, it's going to have to be a squared conversion, which means we need to do it twice. 1.094 yards in 1 meter. Yards times yards is yards squared, so that comes out. Meters times meters gives me meters squared. Now, I need to go through the process of converting those square meters into square kilometers. And we were right, 1,000 meters is 1 kilometer. But we're trying to get rid of square meters here, and we need square conversions. So I just need to do it twice. My meters cancel here and here. Now I have kilometers times kilometers, and now I can put that number and conversion in. 6,600 divided by 1.094 divided by 1.094 divided by 1,000, and then again by 1,000, two significant figures, because that's all that is given to me in this measurement. I would get 5.5 times 10 to the negative third square kilometers. So that would be the result of our conversion. That would be ultimately what we had to do. So, again, if we're looking at it from this standpoint, anytime we have a square or a cube unit here, unless we have a direct conversion between that unit and the unit that we're trying to find, what we'll need to do is find a single unit conversion, conversion of distance, usually some kind of conversion that is singular, and then do that conversion however many times there are in the exponent. So for a square, that means that we're going to do the conversion twice. If this was a cube, we would do it a third time as well. And if I have a multi-step conversion like this, where I've got to convert it from one unit to another, and then again to something else because I don't have a direct conversion, then I would need to do each one of those conversions 2 times in this case, or 3 times if it were that way as well. All right, any questions about this example? All right, then let's do one more example. And we'll do it just like we did this last one. We'll open it up and we'll try to get some conversation going, or at the least put it in a position where we can talk through it if we want. And during this time, feel free to talk to each other, put out some thoughts in chat, put some thoughts out to the collective whole. The best way for you to learn is to learn together. And so if you're really struggling with something, pose a question to your classmates, see see what they can do to help you out as well. Okay. Problem here is simple. Convert the density of gold, 8.97 grams per milliliter, to pounds per cubic centimeter.
Oh.
So I'm going to lay out here for a couple minutes, let you kind of work on it. Again, feel free to drop in and ask questions of each other, and we'll come back in a few minutes and
grams to pounds.
answer here.
Like that. Okay. So we're gonna have 0.4536 kilograms over 453.6 grams. So that'll take care of that. Because we're trying to get to pounds per cubic centimeter. So that, wait, what? Ah, damn it. That don't work. That don't work. Okay. 8.97 grams over 1 milliliter times. Okay, we're trying to get grams to pounds. What we got? Come on. 1 pound equals that many kilograms. That many kilograms equals that many grams. So, oh, wait, okay, no, that does work because. People hear me? I hope not. All right, let's try that again. 0.4536 kilograms over 453.6 grams. And then 1 pound. 1 pound equals that. So we're going to do 1 pound there over 0.4536 kilograms. Okay, so gram, but this is cubed. So we're going to like, no, that's centimeters. Okay, so bam, 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 bam. And we're left with pounds. And then, how do we do the centimeter thing? We got milliliter to cubic centimeter. So we're that volume, cubic meter, liter, liter, milliliter, liter.
It might be easier if you take the. See.
Oh my God, I'm not muted, am I?
No, you're not.
Oh
You
my
haven't been this
God.
whole time.
Son of a. All right. What were you gonna say?
I thought I had it and I lost it.
Okie dokie.
So I'll start by thanking Jacob for breaking the ice there, because that seemed to help a little bit. So as you heard, there's one part of this that's definitively obvious, and that is that we have to go between grams and pounds. Now, since those two our values are equivalent to each other, we can convert it directly. And 1 pound is equal to 453.6 grams. So let's go take a look over here. Bring this over. All right, so one of our conversion factors was that 453.6 grams is equal to 1 pound. And so if I took my 8.97 grams per cubic centimeter and use that conversion factor, 453.6 grams in 1 pound, my grams would cancel out. I'd end up with pounds. Question is this. What do I do now? That takes care of the grams. What do I have to do to take care of the cubic centimeters, or the milliliters rather? Well, and this is where it is important to know our definitions. Cubic centimeters and milliliters are by definition the same thing. Just like cubic decimeters and liters are the same thing. Unrelated to this problem, but something nice to have in your back pocket should you ever need it. So from that standpoint, 1 milliliter and 1 cubic centimeter have the same value. Milliliters and cubic centimeters cross. 8.97 divided by 453.6. 3 significant figures is 1.98 times 10 to the negative second pounds per cubic centimeter. And that really is all that there is to that one. So we're at the end of our time for today. Thank you all for coming to our first review session. Remember, we'll be doing sessions here virtually every Monday from here on in, either in forms like this or through a virtual activity, or those also are what we'll do for your exam days. If you have any questions, again, reminder, the quiz will come available tonight at midnight and will be available all day through 11:59 p.m. on Tuesday. You have any time to take it. You can take it in any 30-minute window that you have during the day on Tuesday. If you have any questions, feel free to email me or send me a remind. But if there are no questions for right now, then you are dismissed for the day. Have a good afternoon.
I do have one question.
All right.
I do not have a like a webcam to take those tests, the proctor tests. So do I just need to go out and get one, I guess? I don't know.
That's probably something you'll want to do eventually. What you can do in the meantime, I believe the library has webcams that you can check out for a 24-hour period. or you can actually take your quiz at the library or at I think the Summers building has a computer lab that has a couple of webcams on it for taking tests. You could do that as well.
And then I had one more question. Was there a test we were that we were already supposed to have done?
No, no, there's nothing due yet. There were some assignments and smart work that were due last night. There were some grade scope things that were due throughout last week.
Yep, I had those done. I just wasn't sure because I saw it on the remind that you were talking about the test or proctor. So
Well, the bonus deadline for proficiencies was last night, so I know a good probably about 2/3 of the students did their proficiencies over the past weekend, and that did require proctoring, yes. But if you missed that, you can easily do it this week and get full credit. You'll be fine.
okay, thank you.
All right, you're welcome. Anybody else have a question? All right. See you next time. Oh, yes, Jacob. The post lecture is on smart work for today. It's more unit conversion practice. And that's the best way to give you all as much practice as possible and give you feedback as opposed to grade scope. So yes, it is in smart work. It's also listed in the syllabus as being on smart work as well.